Welcome to this session of Understanding Human Anatomy. In this video, I will talk about the bones of the forearm, the radius and the ulna. The ulna is the medial bone, the radius is the lateral bone when in anatomical position. So when the hand is supinated. I'm going to start by sketching in the ulna. And I'll start by going up and around and then down. The ulna has a little needle-like process called the styloid process, and then the head of the ulna is distal. That's how I'm drawing in right there. Then we'll come back up and complete this. The ulna has a deep groove to fit in the trochlea. Now, let's add some labels. The head of the ulna is distal. This is unusual for most bones. Usually the head is at the proximal end of the bone, but the ulna is an exception. The head is distal. And I said there was a styloid process and the term styloid comes from the word stylus, which means needle. So this is a sharp process. At the proximal end, we have a notch. The trochlear notch. And the trochlear notch is the articular surface for the ulna with the humerus. So this is the trochlear notch in here. And this is a bit misleading looking at it in this view, because the trochlear notch goes deep into the screen and then up and around. It's roughly a semicircle in shape. So the trochlear notch, and the superior part of the trochlear notch is the olecranon process. The olecranon process. Now, when you look at the elbow, or when you palpate your elbow, you feel the bony tip of the elbow. Very prominent when you have your elbow flexed. That bony tip of the elbow is the olecranon process. Now there also is a slight depression over here at the lateral edge of the trochlear notch and the shaft of the ulna, and this is called the radial notch. And the radial notch is a shallow articular surface that articulates with the head of the radius. So the head of the radius sits in this tiny groove and rotates within there. Now, the radius, we'll start with the head of the radius, and I'm going to draw the radius reasonably far apart from the ulna so that you can see the relation of the head of the radius with the ulna. So here's the head of the radius. And then radius tapers into a neck region. And then we'll go down the shaft of the radius. And the radius also has a styloid process. But the radius is rather wide down distally. Let me clean up my drawing a little bit here. Go again with the styloid process, and then we have a rather broad articular surface and another groove, and then the radius ascends up, and then the radius has an elevated area right here, and this is the radial tuberosity. Now let's put in some labels. The head of the radius, the neck of the radius, the tuberosity, of the radius, and the tuberosity of the radius is an important structure to know and remember, because the tuberosity of the radius is the insertion for biceps brachii, and it's here on the anterior surface of the radius. Now, I said there was a styloid process, just like we had in the ulna. Right there, and we have a notch on the medial side of the radius, the ulnar notch, and the ulnar notch is an articular surface for articulating with the head of the ulna. So each bone has an indentation, a notch, which is an articular surface, and the notch on each bone articulates with the head of the other bone. Now, the radius and the ulna both articulate with the humerus. The radius with the capitulum of the humerus, and the ulna with the trochlea of the humerus. And these two bones articulate with each other. The head of the radius with the radial notch on the ulna, the head of the ulna with the ulnar notch on the radius. And these two articulations, the one between the head of the radius and the radial notch of the ulna, is the proximal radioulnar joint. And this joint is a synovial joint. Okay, a synovial joint, so that there's a small space. Again, I've exaggerated the space between the bones. There's a space between the bones that's filled with fluid. This joint is actually continuous with the joint between the head of the radius and the capitulum and the trochlear notch of the ulna with the trochlea of the humerus. There's actually one big joint cavity with all three joints. At the distal end, down here, we have another synovial joint. This is the distal radioulnar joint. And again, as I said, this is a synovial joint, so there is a space between the bones which is filled with fluid. The ulna does not articulate with the wrist bones, with the carpal bones. The radius articulates with the carpal bones at the distal end. Now, there's a third joint between the radius and ulna. And that third joint is a type of joint called a syndesmosis. And a syndesmosis is a type of joint that does not have a fluid-filled space between the bones, but rather is made up of strictly ligament. So let me draw this in here. I put the boundaries of this ligament. Now I'm just drawing in some lines to indicate the fibers in the ligament. Again, it's going to be connective tissue proper, and it's going to be holding these two bones together. This joint is called the interosseous membrane. The interosseous membrane. I put the label in blue. The membrane I drew in blue, but I put the line in black so it doesn't get confused with the lines I drew on the interosseous membrane. The interosseous membrane is there to keep the two bones close together, but is also necessary to transmit force. And that's something I will continue talking about on the next slide. In this slide, I've added a schematic diagram of the radius and ulna and their articulations with the humerus and the carpal bones. So we have the distal end of the humerus up here, two trapezoids, the radius and the ulna. The narrow end of the radius is at the proximal end, the narrow end of the ulna is at the distal end, and then we have 8 boxes down here to represent the carpal bones, the bones of the wrist. The interosseous membrane is vital for transmitting force from the radius to the ulna. If there is a force generated through the wrist and hands, and we'll draw an arrow to indicate that force. I drew the arrow in red. a force coming through the carpal bones from the hand, it has to be transmitted to the radius, because the radius is the only bone that articulates with the carpal bones. But the radius comes to a narrow point up here at the humerus, and it's articulating out at the lateral epicondyle area of the humerus. And if all the force came through there, then it might cause the ulna to fracture at the capitulum. But because of the interosseous membrane, and notice the direction of the fibers, they run inferiorly as they run medially from the radius over to the ulna. As the radius is pushed in this direction, it's going to tug on these fibers. It's going to tug on these fibers so that there's going to be a transmission of that force from the radius to the ulna. Transmission of force from the radius to the ulna. And so that the force that originated down here in the wrist and hand is transferred over to the ulna and then the ulna in turn can transmit it to the humerus. And the trochlea is a much stronger attachment, much more solid attachment, and it transmits the force much more effectively and without putting the bone in danger. So the interosseous membrane is a joint that holds the two bones together, but more importantly, it transmits force from the radius to the ulna, so that force in turn can be transmitted to the humerus. In the next video, we're going to look at the carpal bones, the bones of the wrist. Thank you for your attention.